Bismillahirrahmanirrahim. Dear students of 10th C, Assalamu alaikum. I am your teacher Muhammad Ilyas. Dear students, this is our ninth interaction regarding chemistry for Cambridge. Our today's topic is the reactivity series, and this is from your book, chapter number 12. And according to CIE syllabus, topic number 9.2, subtopic C to D. Dear students, our objectives are as follows. Inshallah, we will be able to understand the action of heat on the carbonates of the listed metals and relate thermal stability to the reactivity series. Secondly, we will focus on the order of reactivity from a given set of experimental results. So, keeping in view the objectives, we are going to start from the thermal decomposition. First of all, we have to understand what is thermal decomposition. To decompose means to break something into simpler parts. In chemistry, this could mean breaking a compound into its elements or into simpler compounds. Decomposition reactions involve heat, called the thermal decomposition, or catalysts, called the catalytic decomposition. You only need to learn about the decomposition of carbonates and hydrogen carbonates, and over here we are going to focus on the metal carbonates decomposes to form a metal oxide and the carbon dioxide. For example, the calcium carbonate, when we heat it, it gives us calcium oxide plus carbon dioxide. So this is called the thermal decomposition, when we heat any metal carbonates and it break down into its respective oxide and carbon dioxide gas is released. The thermal decomposition of metal carbonates, all the metal carbonates, as I mentioned earlier, when heated to form carbon dioxide and a metal oxide, and this process is called thermal decomposition. Here are a few examples given on this slide: calcium carbonate, copper carbonate, magnesium carbonate, sodium carbonate, and zinc carbonate. And you can see all these carbonates are going to break down into its respective oxides, and plus carbon dioxide gas is released. Dear students, remember this point: the thermal decomposition of group 1 metal carbonates such as sodium carbonate requires a tremendous amount of energy. A Bunsen burner is not enough to break down or decompose the group 1 metal carbonates except the lithium. Dear students, the apparatus required for this thermal decomposition is shown on this slide. We need the eye protection goggles, test tubes 2 per carbonate, a right angle delivery tube, spatula, Bunsen burner, and clamp stand. You can see the arrangement of this apparatus. Now we are focusing on the action of heat on the metal carbonates. We have to take a very small amount of any solid carbonates in a dry test tube and then place it on the Bunsen burner, as you can see from this diagrammatic representation. And then we have to place 2 cubic centimeter of lime water in another test tube. Heat the solid gently at first for 2 minutes and then more strongly for 8 minutes, so that this metal carbonate decompose into its components. Test any gas with the lime water. For example, we are going to decompose the calcium carbonate, copper carbonate, magnesium carbonate, and zinc carbonate. First of all, we have to note down the appearance, means the color of these salts. Then we have to check the carbon dioxide is produced or not, and what is the color of the residue, whatever left, and then we have to make the conclusion. These tests I have this slide to show you the result of these tests. You can see the calcium carbonate, its appearance is white solid. Carbon dioxide is produced, means the gas which is coming out from this carbonate after heating is going to turn the lime water milky. The residue which is left is again white solid. Conclusion: calcium oxide formed, but it needs very strong heating. Copper carbonate, green solid, carbon dioxide is produced, and the residue which is left, that is of black color. And the conclusion is that copper oxide formed. Magnesium carbonate, this is white solid, carbon dioxide is produced, and the residue is again of white color. Magnesium oxide formed. Zinc carbonate, white solid, carbon dioxide is produced, and the yellow solid which turns white when cool, and zinc oxide is formed. This is our conclusion. So you can see these experimental results. Now on the basis of these results we can make this table of different carbonates. You can see, dear students, it decomposes more easily down the reactivity series. Thermostability decreases. The result of these experiments shows to us that the decomposes more easily when we move down the reactivity series. It means the thermostability decreases. One more thing I would love to discuss over here: the position of a metal in the reactivity series does not just indicate its reactivity as a metal, but also has implications for the chemical properties of its salts. This is well demonstrated by the thermostability of the metal carbonates. You can see the potassium carbonate and sodium carbonate not affected by the heat, while the calcium, magnesium, zinc, lead, iron, copper, they can decompose on heating to give carbon dioxide gas and the metal oxide, while the silver carbonate decomposes on heating to give silver oxide and the carbon dioxide gas. Dear students, silver oxide produced is thermally unstable. Silver oxide further decomposes to silver, as you can see from this equation. So on the basis of this we can make this reactivity series. We have to place the potassium at the top, then sodium, then calcium, magnesium, aluminium, zinc, iron, lead, copper, and then silver. So this is the reactivity series on the basis of the thermal decomposition of the metal carbonates.